Hi, this is Mrs McTaggart, and in this video we're looking at arcs and sectors. This is the third lesson on the kind of working backwards ones, where you're given the area or you're given the arc and you have to get either the angle or the radius or the diameter. I'm doing this a different way to my previous video, which is still out there. If you're good with change of subject, brilliant. This formula, I'm using the triple formula method, I don't know what else to call it, is really, really good for working backwards, particularly if you're not great at change of subject, because it uses the same principle that you do in sine rule, and generally you're pretty good at sine rule. So let's have a look at this in action. I'm going to do 4 examples. So on my first one, I am given a small sector, and I am told what the arc length is. So first thing is, make sure you read it and know you're working with arc. So that means I'm not using the area part of my formula. Hopefully you've seen the other videos and you're familiar with the formula. It's arc over circumference formula, area over area formula, and angle over 360, because your angle is out of 360. I'm told the diameter is 15. So I am using arc length, so we're just going to scrub out the area bit, and we're using arc over pi d. So I'm just going to plug everything into the formula and then worry about where we go from there. So I'm told the arc is 11, so this is different. This time I've got a number in instead of writing arc. So I've got 11 over pi d. Now my diameter is 15, so I've got pi times 15. And that equals my angle, I don't know, so I'm just going to call my angle x over 360. Then I want x on its own, so the thing that's in the way is this 360. That stands for divide by 360, so I'm going to cross multiply and take it over this side. So I will have 11 over pi times 15. And I'll have the times 360 as well over there. There's different ways of writing this. Do I want to write it on the top of the fraction? Do I want to leave it separate like I've been doing in previous videos? It really doesn't matter. I might want to leave it as this, times 360 equals x. The choice is yours. I think I would probably bring it up to the top, but we can just still type it in as is. So I'm just going to put it back up on the top. So times 360. And then if you've got like your fraction button in the calculator now, when you type it in and it comes up with a square over the square, you can just go type that in using the fraction button and it makes it dead easy. If you don't do that fraction button, you must press equals after the top line. Okay, so you do 11 times 360 divided by and get a bracket around the pi times 15. I know some people are sometimes working with older calculators and have to do things a little bit differently. So we've got 11 times 360... and we're dividing that by pi times 15. Sorry, I'm typing into my calculator here. And I get 84.03. I think that's safe to say 84 degrees. When it's angles, do you know it's the only time that I'm happy for pupils to do it to the nearest whole number is if we're talking angles. So I'm getting an angle of 84. Let's have a look at another one. So that was using arc. This one, I am working with area. I'm told the area of this sector and I'm told the radius. So I'm using the area part of the formula. So area is 43, so that goes on the top. My radius is 4, so I've got pi times 4 squared. You might want to show off and just turn that to 16 at that point. I'm going to leave it as pi times 4 squared equals my angle. We don't know, so we'll call it x over 360. Again, I'm going to cross multiply the 360, so I'm going to have 43 times 360 all over pi times 4 squared, and that equals x. Go to your calculator and type that in. And in this case, we get 30.796. So I'm going to round that to 31 degrees. So I've shown you 2 examples where we're to get the angle. Let's look at this one where we are finding the length of the pendulum. So a pendulum, you've maybe all swung at something on a bit of a string before, or a yo-yo. In my day, it would have been a conker, but they're not allowed now, on a bit of string. And it makes this lovely arc. It makes this lovely sector shape. So let's look what the question tells us. They tell us the arc length, so we're using the arc part of the formula. They've told us the angle, so we know our angle. The one thing we don't know is our radius or our diameter, but they're connected, so we can find our diameter and then get the radius, but we're not going to worry about that. So we're not using the area part. So let's plug in. And we're just going to create a wee bit more space here, because I don't have a lot of room for my work in. Okay, oopsie daisy, let's straighten you up. Right, so I have my arc length is 28.4. So I've got 28.4 over pi times d. I know that my angle is 65 over 360. Now D is my unknown, so we're going to the sign rule where we fully cross multiply here. So I want my letter on the left, I want my D on the left, so I'm going to write it as 65 times pi times D equals 28.4, no room, times 360. Now remember, we're trying to find D, so the thing in the way of the D is the times 65 and the times pi. You can take them collectively as 65 pi. So I then have 28.4 times 360 divided by 65 pi to go work out, or 65 times pi if you prefer. Go to your calculator and type that in using your lovely fraction button, and you get 203.4. I've forgotten what my units were from the question. It was centimetres. Now that seems like a really big pendulum, but do you know what? 2 metres long. I don't know what the question was about because I took out the top bit of the question. But there's your answer. Okay, so this is where I like this formula when you're working backwards, because you're using the same process as you did when you're doing sign rule. I've got one more for you. This was from the 2024 exam, and it wasn't particularly well done because it was really sneaky, right? This one told us the arc length and then it asked for the area. So what most candidates did is they had to do the formula, they're working twice over, and it was only worth 3 marks, and mistakes got made. So option 1 is you could use arc, because obviously the thing that's missing here is the angle at the centre. So you could use the formula for arc, forget the area bit, go do arc and get your angle, and then go redo the formula from lesson 2, where now you know your angle, get your area. But this formula allows us to bypass all of that. So take you back to sign rule, you tick off what you know and what you want to know. I know my arc, I want my area, I know my radius, and obviously if I know my radius then I also know my diameter. I can completely bypass the whole angle part to it. Now this has only come up once. Is it likely to come up again in 2025? No, but they could do it again in 2026 or 2027. Who knows when you're watching this video? So we're going to do it this way. So I know my arc is 15, so I'm going to write 15 over pi times d. My diameter is, so remember this is the radius because that's the centre of the circle. So my diameter is 24 equals my area, don't know that, over pi r squared. So pi times 12 squared. We want area on its own, so this is going to get cross multiplied up to here. So I have 15 times pi times 12 squared all over pi times 24 equals my area. And if you type that in, we get 90. So the area is 90 centimetres squared. And what I liked about that is it was only worth 3 marks. I only did 3 lines of working. But there was that other way of go get the angle first and then apply it into the formula for area. But it was an awful lot for 3 marks. So this is why I've tried down this formula as well. And I definitely think it helps if you're not great at change the subject or working backwards. If you didn't like your working back volume and things like that, this will help. Anyway, thanks for watching.